Hi students, today we are going to discuss the effects of electric current. In the previous class, we discussed about the basic concepts of this chapter. What are the good conductors, bad conductors, example for these conductors and insulators that we have discussed in the previous class. Also, we discussed the testing methods to check whether a substance is a conductor or not. We discussed in the previous class about the testing methods to check whether a substance is conductor or not by taking a battery. Is a battery and connect a wire, then a bulb.
Here you can see the testing of conductivity of rubber, glass, stone, aluminium, copper and iron.
This is the point A, B. Place the material that you want to check the conductivity, place here. Then if the bulb will glow, then we can found that the material is a good conductor. Otherwise, it is a bad conductor. Okay. If you take iron rod and place here, then the bulb will glow. It indicates that the material iron is a good conductor of electricity. So we discussed in the previous class about these examples and also the testing methods. If you take liquid, if you have to check the conductivity of a liquid, that means lemon juice, then you can you can change this tester as like this and place a beaker here. If you add lemon juice up to this level, then you can see that the bulb is glowing. What is indicates lemon juice is a good conductor of electricity. Okay, if you add lemon juice, then the bulb will glow. It indicates the acidity and also the conductivity of the lemon juice. Okay, that we discussed. But today we are going to discuss three effects of electric current. Three effects of electric current. First one is heating effects. Heating effects of electricity. Heating effects of electricity. So take a battery. This chapter mainly goes through electric current. So take a battery is a representing methods of a battery. It is two cells. Two cells. It includes two cells. That means here this in this line indicates the positive terminal. This is negative. This is positive. This is negative. So take positive here, negative here. It's a battery. Okay. Then connect this with a bulb. Connect it. A battery is connected with a bulb. A bulb has a filament like this. A bulb has a filament like this. So when the current passes from this positive terminal through this, current is passes through the circuit and it passes through this bulb and then reaches to the negative side. It is a complete circuit. Okay. So when this electricity passes through a bulb, it produces light and also heat. Okay. This filament tungsten, this filament example tungsten, it produces light and also heat. That is heating effect. Also it produces light. Okay. In iron box, you can display this as an iron box. Iron box uses the heating effect of electricity purely. If you connect iron box in this circuit, iron box does not glow but it produces a lot of heat. It is a purely heating effects of electricity. The example iron box is for heating effects purely. Okay, if the cells are less current, then you can displace this incandescent lamp with an LED. Incandescent lamp with an LED. Are you hear the word LED? Light emitting diode. LED. Okay, LED, light emitting diode. It also uses the heating effect and also light produced by electric current. LED works on less current. LED works on less current, and this is positive terminal and this is negative terminal of this LED. How you can identify this terminal? The leg of the positive terminal, it is positive and it is negative. Positive leg is larger than the negative leg of an LED. LED is a commonly using light in our homes today. Okay, incandescent lamp CFLs are also displaced by the LED. Is a more powerful. It needs only less energy and it produces a large amount of light. So that is why we are using LED in our homes, LED lamps in our homes. Okay, that is heating effects of electric current. There is a question from here. What are the properties of an LED? Okay, what are the properties of LED? LED is a bulb which glows even when a weak electric current flows through a circuit. Then LED has polarity. It means that the positive terminal of LED is always connected with the positive terminal of the battery. Okay, the positive terminal of the battery is always connected with the positive terminal of the LED. Okay, the positive terminal is slightly elongated than the negative terminal. Okay, that is this longer leg indicates the positive and shorter leg uh, indicates the negative terminal. So you can connect this end with negative and this end with the positive terminal of the battery. That is the connecting method. Okay, then high efficiency. LED has high efficiency and then less power consuming than low cost. LED is cheaper than other bulbs. Then high durability. LED is high durable than the other bulbs. So here we discussed the heating effect of electric current. Then we have to discuss the magnetic effect. Magnetic effect of electric current and then the chemical effect of electric current. Chemical effect of electric current. Okay, the next effect of electric current is magnetic effects. Magnetic effects. What is a magnet? Magnet is here. It is a magnet like this. It is a magnet. A magnet has two poles. Two poles. Okay. It is north pole. It is south pole. Two poles. Monopole does not exist. Okay. Any magnet consists two poles. Monopole doesn't exist. Two poles are north and south poles. This is a magnet, and you can see N is marked here and S is marked here. Then is a compass needle. Okay, it's a compass needle. You can place this compass needle here. What happens? This compass needle consists of a north and south indicating needle. Okay, this is the needle of the compass needle. Okay, then we place this magnet at the adjacent side of this compass needle. Then the north pole will goes when the south pole goes through here and north pole comes to here. When you place a compass needle behind a magnet, then you can see that the north pole, that means a red indicated needle is coming towards the south pole. You can see here, but you may not clear it, okay, because uh, compass needle only deflect in this way. If you place in this way, then you will not get the correct reading, but you can see it, okay. It is the south pole, it is south pole. Then this red indicated red needle part is come towards the magnet, okay, you can see it. When I move this magnet, the compass needle also moved with this magnet, okay. This is the south pole, and you can see the compass needle moves with the magnet, okay. Here we are going to study the magnetic effects of electric current. Magnetic effects of electric current. So we need a battery. Electric current. So we need a battery. This is a circuit, and I place a compass needle here. This wire just rotate and connect here. Okay. This compass needle is rolled with this wire in which the current is passing. So what happens? This is the magnetic needle. When we close this circuit, the current will start to flow through this circuit. So the magnetic needle will deflect. If you have a battery and a wire, then place a compass needle here. If you connect this wire with the battery, then you can see that the magnetic needle deflect. Okay, and you can see the deflection of the magnetic needle of this compass. Why it is? When the electricity passes through this wire, it produces a magnetic field around it. That produces a deflection in this compass needle. Okay, it indicates that electric current can produce magnetic field. Okay, even when a small current flows through a wire, it produces a magnetic field around the wire, and it can produce a deflection in the magnetic needle. It can produce a deflection on the magnetic needle placed under the wire. An electric current can produce magnetic field. By using this circuit, you can test the conductivity of different material. Okay, if the circuit is closed, then the magnetic needle will deflect. So you can change the circuit like this, and place a beaker here and place a beaker here. You can test the conductivity of lemon juice, vinegar, tap water, vegetable oil, milk, honey, distilled water, fuel, seawater, salt water, etc. by using this tester. Okay, it uses the magnetic effects of electric current. If the circuit is complete, then the magnetic needle will deflect. It indicates the conductivity of the lemon juice. If you add lemon juice here in this beaker, then you can see the deflection of the magnetic needle. It indicates that the lemon juice is a good conductor of electricity. Okay, is a good conductor. Then also vinegar, tap water, vegetable oil, milk, honey doesn't conduct electricity. Distilled water may not good conductor, and fuel is not a good conductor. Most probably fuels doesn't conduct electricity. Then seawater, salt water. These are good conductors of electricity. You can check this conductivity by using this device. So we discussed the heating effect and magnetic effect. At last, chemical effect of electric current. In this chemical effect, we have to study, in this chapter we have to study two topics. First one is electrolysis and the second one is electroplating. Okay, first one is electrolysis. Second one is electroplating. These two these two topics are very important. So first we look for electrolysis. Okay. Okay, let us find what is electrolysis. Okay, what is electrolysis? For that, take a beaker, then a battery. Okay, it is the process of decomposition of a chemical compound in a solution by passing electricity through the solution. This process is due to the chemical effects of electric current. It is the process of decomposition of a chemical substance by passing electricity through a solution. So take a solution and pass electricity through the solution. Then this solution will decompose into another compound. If it is H2O, then we have to pass high electric current through this circuit. Then it decomposes into hydrogen and oxygen. This water is split into hydrogen and oxygen. This process of making compounds by passing electricity through the solutions are called the electrolysis. Okay, are you get the idea? The process of decomposition of a chemical compound in a solution by passing electricity through the solution is due to the chemical effects of electric current. So, electric current can change the chemical property of this compound and it splits into another compound. Okay, then what is an electrode? Electrode, it is the connecting material in between the solution and the electric wire. Okay, what is an electrode? Electrodes are metal rods which helps to connect electrolyte and battery. It helps to connect this battery and electrolyte. Electrolyte means a conducting solution. So it helps to connect the electrolyte and battery. It's a metal rod. You can use metal rods based on your application. Okay, it should be a metal rod. That rod, that connecting wire, that connecting material is called the electrode. Then we have to check the electrolysis of water. What are the products when water undergoes electrolysis? So we discussed that it's a water, H2O. It's a carbon rod. Carbon is used as an electrode. Okay, we discussed what is electrode. It's a connecting material. Here it is carbon. Okay, this carbon rod, and then it is connected to the battery. Then it is connected to the battery. Some huge amount of electricity is passed through water, then it splits into H2 and O2. Okay, so H2O2 is split as H2 and O2. Then H is positive, so it goes through the negative terminal. Okay, H2 and oxygen is negatively charged one, so it goes through the positive end of the battery. Okay, O2 is goes to the uh, positive electrode, and hydrogen is deposited. Hydrogen gas is evaporated. Hydrogen gas is evolved at the negative electrode of this device. Okay, of this apparatus. O2 will goes to the positive electrode and hydrogen will goes to the negative electrode. Okay, negative electrode means negative part of the battery is connected to this electrode. Okay, this is the products Electrolysis. What are the products when water undergoes electrolysis? When water is electrolyzed, that means passes electric current by using carbon as an electrode. Oxygen bubbles formed on the electrode which is connected to the positive terminal. Okay, oxygen is bubbles are formed in the positive electrode, and then hydrogen bubbles are formed in the negative electrode. That are the products when water undergoes electrolysis. This electrolysis was invented by William Nicholson in 18th century. Okay. Okay, our next application is electroplating. Okay. Second application is electroplating. What is meant by electroplating? For that, we need a beaker, then connect with a battery. Here there is a metal plate. Here there is a plate, and here also another plate. Then what is electroplating? It is the process of depositing a layer of any desired metal on another material by means of electricity. By means of electricity, we can make a coating on the other material. Okay, take make this apparatus and take copper sulfate CuSO4, copper sulfate CuSO4 solution as an electrolyte. What is meant by electrolyte? The conducting solution. So CuSO4, copper sulfate is an electrolyte, and copper as an electrode. Copper. So take two copper plates as an electrode and copper sulfate as electrolyte. Then pass electricity to this solution. Then the anode material is deposited on cathode. Then the anode material is deposited on cathode. Anode and cathode. Anode is positive terminal, cathode is negative terminal. Anode is positive terminal. Okay. Anode is positive terminal and cathode is negative terminal. Cathode is negative terminal. This copper rod is anode and this copper plate is cathode. Anode means positive, cathode means negative. Then the anode material is deposited on cathode. Here we choose these two material as copper. Then the copper material from this plate is deposited on this plate. So the copper material from this plate is deposited on the other plate. That is happening in electroplating. The material on anode is deposited, is make a coating on the cathode. That is the process of electroplating. Okay. The electrolyte is usually the salt solution of the metal to be coated. Here copper is to be coated on the other copper material. So we choose copper sulfate CuSO4 as the electrolyte. Which is the material to be coated? That salt solution is to be taken as the electrolyte. It will help to make the coating possibly. What happens when this electroplating is happening? What is the process of electroplating? This is the process of making coating on this coating. But what is the process? Here, when these negative electrons coming from this battery, negative electrons will pass through this metal plate and will reach to here. Then these electrons appear here. But This CuSO4 will split into Cu plus Cu2 plus and SO4 2 minus. This Cu2 plus moves to the negative terminal, Cu2 plus Cu2 plus, and SO4 will move to here. SO4 2 minus is moves to this anode. Then this 2 minus electrons deposited here and electrons will move like this. Okay, then this copper from this material is dissolved in this solution and this Cu will move to the anode. This circuit is complete. Okay, this so for the completion of the circuit, copper from this side is moved to the this plate. It forms the plate. It forms the film coating by using this material on this material. The copper material from this plate will move to the this plate. Okay. And what are the applications of electroplating? We have to discuss the applications of electroplating. First one, it helps to make coating on metals to prevent rusting. Okay, it helps to prevent rusting by making coating on the material like iron. Iron is most probably undergoes rusting by reacting with water. So the coating of zinc on iron rod helps to prevent rusting of the iron rod, and also other metals can use this application. Okay, then chromium plating can resist scratches and wear on bathtubs, car parts, and the gas burners. Then bicycle handles, bar wheels, rims, etc. It also gives bright, attractive appearance. And chromium coating is it gives a bright appearance on these materials. So we use chromium coating on different parts. Okay, silver silver plating is done on ornaments and jewelry items. Silver and gold plating is done on ornaments and jewelry items. It helps to make a coating on the surface of cheaper material. Okay. Then electroplating of tin on iron helps to prevent the spoiling of food items by preventing the direct contact with iron and the food materials. If there is a contact between the food material and iron material directly for a long time, then it is spoiled. It prevents the coating produced on the iron by tin. Okay.